Hey y'all, this is Derek, and this is section 3.5, which is going to be point slope form of a line. And so it's here in the box. I just wrote it a little bit larger up here so I can kind of point at it. And what this is our slope formula, right? If I divide over this x minus x1, this just becomes change in y over change in x. So all it is our slope formula solved around for the y's. And what it does is it gives us sort of an alternate version of looking at lines. This can be easily reduced into slope-intercept, which I'll show you in a second. But in the last section, if you remember, I would generally get a point and a slope and put them in for the y, the m, and the x, and then use that to solve for b. This you'll see, and then you have to go back and write the equation. This is just going to kind of spit out the equation at the end. So let me show you how that will look. I think I'm going to take a second and rewrite this right here big so that you can see me actually plugging stuff in. Okay, so write an equation line with a slope of 3, so we know m is 3, and the point -1, -3, so that's our point, our x1, y1. And then the x and the y in this case are just going to remain the variables, so they are the x and y that we're going to see in the equation. Use point slope form. So y minus -3, I'll clean that up in a second, equals m is 3, and then x minus -1. I'll clean that up as well. So then kind of fixing up those double negatives, y minus negative be y plus 3 equals 3, x minus -1 would be x plus 1. And that is point slope form. And there are actually some good things about this that I'm not going to go into too much in this course because we need transformations and those don't happen until the next course. But there is an advantage to this that I'm going to just kind of gloss over for now. Part B is write the equation in slope-intercept form. So there's something we are a little more familiar with. So I'm just going to distribute that 3 as I bring it down here. So I don't have a lot of room to write. 3x, and I'll make a plus 3, and now I'm going to subtract my 3 over because I'm trying to get y by itself because that's slope-intercept. So that gives me y equals 3x, and yeah, it's cool, those drop out. So that just means we have a line through the origin, and my y-intercept is 0. So then if I go to graph this, I can just 0, 0, right, because plus 0 there. And then my slope is 3, so it's going to run 1 and rise 3. Run 1, rise 3. Number 2, sketch the line with the given slope passing through the given point. So this time they didn't give me a y-intercept, but that is totally okay because remember, if we have a point and a slope, we can graph it. So our point is where we're going to start when x is -6, y is 1, and then that slope is -2/3. So we're going to run 3, 1, 2, 3, and then we're going to rise -2. So that puts us right there. I'm going to do one more point so I can draw a halfway straight line. And then find an equation line, write your answer in slope-intercept form. So I could do that a couple of ways. I'm going to do the hard way first. So I'm going to use point slope form since that's what this is about. And sometimes this would be our only choice. So I'll show you the shortcut though on this in a second. So let's see, where's my point? It's -6, 1. So y minus 1 equals m, which is -2/3, and then x minus -6. So this time, instead of writing minus negative, I'm going to write that as a plus. But be careful with that sign. That's right where folks make errors. And then I'm shooting for slope-intercept, so I'm going to distribute. So 2/3 x. 3 would go into 6 2 times, and then 2 times 2 would be 4. Or you could just think, what's 2/3 of 6? 4, and then negative because of the sign. And then let's add that 1 over, and I got y equals -2/3 x minus 3. So there's my equation in slope-intercept. And if we come right back here to the graph, here's the shortcut I was talking about. If you're drawing a decent line, you can look, if it's going over 3 down 2, over 3 down 2, it is absolutely not ambiguous that that was at -3. So I could skip all that math and go -3 and just get my equation that way. And then lastly, find the x-intercept of the line. I could try to read it, but in this case, if you look, it looks like it's kind of going through -4, but it isn't. You could totally figure out that that's -4.5, but let me show the math over here. So to find an x-intercept, that means we're letting y equals 0, right? And because we're going to be neither above nor below the axis. So this would be 0 equals, actually just write it as -2/3 x minus 3 equals 0. And I'm going to add that 3 over. -2/3 x equals 3. And then to get rid of this fraction, I'll multiply by the reciprocal. And that gets me 6/6, so that's a plain x. 3 times -3 would be -9/2. So my x-intercept is at -9/2 and 0. Okay, Francine is driving into the mountains and stopping periodically to record temperatures at various altitudes, because Francine has too much time on her hands. The temperature at altitude 4,000 feet is 74 degrees, and temperature at 7,000 feet is 68 degrees. Find the coordinates of these two data points for this model in the form altitude temperature. So, okay, and they're telling me that altitude, so that's like our x, and then temperature is going to be our y. So altitude at 4,000 feet, the temperature was 74 degrees, and at 7,000 feet, the temperature is 68 degrees. And then B is find a linear equation for the temperature, y, in terms of altitude x. So to find the equation of a line, we need a slope and a point, and right now I have 2 points, so let's get a slope. So m is going to be 68 minus 74. That's my change in y over my change in x. 7,000 minus 4,000. So that is a difference of -6 over 3,000. And then 6 goes into 35 times, right? So that's going to be -1 if I cancel out a 6 over 500. So that is my slope. So we got, let's do point slope form since that's kind of what this section is about. I'm going to use that point right there. So y minus 74 equals m, which is now right here, -1 over 500, and then x minus 4,000. And I want this y in terms of x, so that means I'm going to want to distribute this through and get that 74 moved over. So y minus 74 will equal -1 over 500x. That would go in 8 times, and it would be positive because of the double negative. And then I add that 74 over. And that would be 6, 7, 8, so that's 82. Okay, so there's my y in terms of x. So then the next part is, what is the slope including units? So our slope was -1 over 500. And now let's go back and see what we were finding. We were finding our x, so change in y, actually, let me start there, is in degrees. So that would be -1 degree per 500 feet of altitude gain. So basically, our temperature is dropping 1 degree for every 500 feet we go up. What will the temperature be at 10,000 feet? Well, now I have this equation down here, so I could just put in the 10,000. So that's going to be y equals -1/500th of 10,000 plus 82. And then doing that, I get y equals 62 degrees. And then what's the temperature at sea level? Well, at sea level, the altitude, which was our x, would be 0. So it's asking what's the y-intercept. And so that's at 82, because we'd have 1/500th of 0 plus 82. So at sea level, our temperature is 82 degrees, or that intercept. And so then what happens is for every 500 feet we go up, it's going to drop 1 degree. On an international flight, a passenger may check 2 bags. These are some pretty hefty bags, each weighing 80 kilograms or 176 pounds, and 1 carry-on weighing 70 kilograms and 154 pounds. That's quite a carry-on. Find the coordinates of these 2 data points for this model in the form kilograms, pounds. So our first point would be 80 kilograms, they're saying goes with 176 pounds, and then 70 kilograms goes with our 154 pounds. Find our linear equation for the weight P in pounds in terms of weight K in kilograms. So I want to put in kilograms, that's the X, quote unquote, and I want to get out weight in pounds, that's the P or Y in this case. And so that would be, probably want to find M first. So 154 minus 176 over 70 minus 80. And you can see if I had labeled these, written them down the other way, I would just get about to get 2 negative numbers, which would be positive. I would have just got the positive numbers. So this is negative 22 over negative 10, or 2.2. So that's our slope. And then I just arbitrarily picked that point and did y minus 154 equals 2.2 x minus 70. And notice at this point, I could also do y equals mx plus b. So if you're not loving slope intercept or point slope form, you can also do it the way that I did it in 3.4. Same thing, just kind of 2 ways to get there. If you're going the pre-calc route, you should probably learn both ways. If you're going 116, you'll see this one a lot, so I'd still probably learn both ways. Distributing, let's see what we get. 54. 2.2x, and then 2.2 times 70, where did that go? Negative 150, well, of course it's negative 154, that makes sense. And then when I try to add that 154 over, I end up with this equation, 2.2x, and the reason I said, well, of course that makes sense, is because if I have 0 pounds, I'm gonna have 0 kilograms, right? Oh, and I just noticed, same thing I did in the notes, I did x's and y's instead of P for pounds and K for kilograms. So I was supposed to find the linear equation of the weight in pounds in terms of kilograms. So this equation should really be P equals 2.2 K. Sorry about that. And then the last 2 pieces of it are what are the slope, including units. So those was 2.2. And the 22, that was the pounds. And the 70 and the 80, that was the kilograms. So it is 2.2 pounds for every kilogram. Okay, and then for part D, we have P equals 2.2 K. And we're asked, what does a 50-pound bag weigh in kilograms, round to 2 decimal places? So the pounds are 50, 2.2 K, and then divide over the 2.2, and then that's going to get us our mass in kilograms. So that came out to 22.727, and it kept going from there. So rounding to 2 decimal places, so that 7 would round the 2 up to a 3. So it should be 2.273 kilograms.